And yes, we are live now. So, hey folks, this is me, Vishwasnan. I'm the host of this DevOps chat series. A lot of time, things have gone really worse in the definition of auto healing and remediation. This entire concept of auto healing was already there in Toyota production system. That is indirectly, but today we are architecting a solution towards it. And today I'm very glad that Tarun Marwa sir is here, and he's going to talk about a lot about how this technology can really impact in terms of security as well as in terms of the governance. And thank you so much, sir, for being on the show after a very long time. So yeah, let's get it started.
Thanks, Vishwas, for hosting me today evening, weekend evening. Yeah, it's been a long time, so I thought of sharing my views on this topic. It seems to be an interesting one, and I've worked with infrastructure a lot. And yes, I think very interesting topic. Yeah, let's go ahead. Yeah.
Sure. How do you manage technology at scale and how security is looked upon here? So, what's the definition of scale according to you?
See, scale up. Whenever we design an application, whether it's a monolithic architecture or microservice architecture, mm, actually the design of the application matters a lot, right? In terms of, is my screen blinking a lot, or is it fine? Sorry to interrupt, because
It's fine, not a problem.
so what's happened is like when you talked about the term self-healing, right? It also depends on the architecture of the application, how it is designed. Is it compatible for a auto scale or not? That's the first question. So you have to, when you are hosting the application and then trying to designing an application and then trying to host into a infrastructure, whether it be web apps into a cloud or into on-premise structure. You need to ensure that your application supports the scalability as an option. Because I have personally working, I have worked and still kind of work in a hybrid environment where I'm supporting the monolithic application as well. So I know the challenges in supporting those, moving those applications to the auto scaling or self healing technologies. It's a broader term, but if you see the current migration trend, not many companies are at that level actually. When we talk about like auto scaling, whether it be a any type of scaling we have. So forget about the horizontal or the vertical auto scaling, which we usually hear about the types of the scaling. We need to first understand how should we design the application to, so that it should be compatible enough to move to it should heal automatically when any infrastructure, any issues, any disaster happens. So it should be able to support that. The application should be able to support that. It should be geographically distributed accordingly. And then when we move towards the, because I have worked in a diversified experience, I have worked in a monolithic as well, still part of it which I'm still working. And now in the middleware also, which I've worked, like where I have worked for where we used to scale. For example, a couple of years back, I had an experience like I was working for an e-commerce based application. Right, during the holiday season, the peak happens, right? Like the Black Friday and the Cyber Monday, in all those sales period, and during the when you consider the Diwali, which went last month. So so these couple of festivals. So during these point in time, we require a lot of scaling. And even if we take the recent example of the how Hotstar is Disney Hotstar is managing the concurrent users as of now. So this kind of scaling, the methodology, the architecture needs to be well enough to handle this scaling. So when we talk about scaling, and when we talk about when we move from the middleware also to the microservices, So here comes the technology called where we this auto scaling and auto healing is self managed by the orchestration framework like Kubernetes. So we don't have to spend so much efforts like in the in increasing a node pod or anything. So this auto scaling when we means like it needs to so usually which is followed is which I have seen is a horizontal auto scaling which is happening very frequently. We try to increase the number of VMs supporting the application. If it's a certain, for example, typical IS based application where we have hosted the application on the IS web the servers, right? So we typically tend to have a horizontal auto scaling where we tend to increase the servers, and then we have a typical load balancer that is on top of the VMs, which is distributing the traffic according to the load which has been happening on the different regions, and then it is how it's been managed. This is called when you call this is called a horizontal auto scaling. Vertical auto scaling is like it used to happen. It is still happening in case of the monolithic applications where we increase the RAM, where increase the RAM or the CPU cores or the disk space for when we do the capacity planning. So this is typically followed in the monolithic architecture, whereas the later one it just follows in the latest architecture, which is the microservice architecture, which is the horizontal auto scaling. So today, like we have moved into a tech scenario where infrastructure needs to be self heal itself on the capabilities. Like it has to because self healing is a broader term actually. When you say it has to automatically recover, respond to the threats, events, and the the security attacks which are happening. It needs to heal. We need to train. We need to train the infrastructure. We have to ingest some kind of AI and ML as well, so that infrastructure learn those things. And whenever those again when that event happens, right, it has to learn, and then it has to evolve automatically. So that's what
Yeah,
the main funda of uh, auto healing is. Like we have to train the infrastructure to reach at that level. Yeah.
yeah. I just want to share my screen, and I will just share an white paper from New Relic. Okay, so
Okay.
I am just saying you why, because it's AI ops
Yeah.
New Relic.
AI
That means,
ops, unfortunately, it's coming into the
yeah,
all everywhere. Yeah.
yeah. Like if you think of something like, even there is a tool called as Instana from IBM. Instana,
Okay.
Instana. Yes, Instana from IBM. No, Instana from IBM. All right. Yeah, this is the one. Yeah. Yeah, this is the one. So there's a lot. There's a lot that is coming up, but I want to really talk about the AI ops pipeline and the actually the white paper which they are talking here. So you can just go about the resources, but what is happening here is very simple. So the ones which are very mission critical, they are just coming back on your dashboard, and the others one are neglected, right? So I think the definition of AI is also changing today. If you think of something like, whatever we had 10 years down the line, it's already changing. I think New Relic really pioneered that way. I think even in the Future Stack talk, they were talking a lot about how they are actually going to improvise the sharding strategies for the SaaS platform, how the databases are coming up. Yeah, like that's how it is. I think AI ops is the new hangama that everybody will want to just be there.
Yeah, of course, it would be the latest Hangama which is going to be there, and
Yeah.
that's what it is. So I've just I was just reading and going on through a couple of the articles which may help us to have a
Sure,
upscaling and
sure.
why it matters to us, and I have shared those content, and I think one of them is like the I
I
think
think
I
you're
have
sharing
already
your screen, right? I think you can just share your screen and you can just show it to them.
uh, like I think I can just share it. So yeah. Uh, so this is what I was just referring to. So I have already talked given a gist about it. So to first of all, to have a self-healing infrastructure, you need to design the solution or the according to it, so that it is fit for the self-healing. So this is what I was talking about. It has to be into the architecture. There's a first phase. When you plan for this kind of architecture for scale in, scale out, and performing the operations, so you need to design the your application accordingly. So this designing an application, as you see, needs to work on a three prolong approach, which is detecting failures, responding to the failures, and log or monitoring failures to give operational insights. And so a couple of recommendations which are since I've been associated with mostly with the Microsoft technology, so I can think of as from a Azure cloud perspective, what helps self-healing means when it talks about coming to the infrastructure. So it doesn't, however, it doesn't talk about the AI and ML part, but yes, with the evolving things, as you are rightly said, as I've also mentioned, you need to train your infrastructure accordingly to learn about new threats and the ways to auto heal, because healing is not only disaster recovery or coming from a failure, it also means coming from a secure potential security breach as well. That's a new definition which has been evolved now. So recommendation, when you see, should it should retry the failed operations and protect the failing remote services, isolate the critical resources. You should isolate and then try to recover them till that time the other part of the traffic can serve the customer requirements. And the load level, perform load level testings, which is also which can handle the traffic. And then failover, so there are a couple of things which can be considered, and block the bad actors which is causing the application throttling the messages. So you should try to ingest that training model to the infrastructure, so that it's auto self heals and then they use the leader election. So the couple of the fault injection and the embarrass the chaos engineering. So this is the common word which has been used, the chaos engineering. So it means, what it means is extending the notion of the fault injection by randomly injecting some data, and then so that it can be uh, you know I think some part of self-healing infrastructure also, I think it's somewhere related to the zero trust, also zero trust architecture also. Why? Because you have to assume that the threat has already happened, and then you try to mitigate. You need to try to mitigate or do remediations. So this is some part of zero trust is also linked to the self-healing, while preparing, while keeping in mind the self-healing when you are designing, right, the self-healing infrastructure. You need to also somewhere think about the zero trust principles. And this is the couple of the things which we have already discussed in the past. So this is where we can have a architecture discussions designed for self-healing, and what things can be around. So use managed services, and then you can just go through all these things which are been there. And the second thing which we will talking about is, I was just exploring like what is the typical the definition of an app scaling. Also, I doesn't I have only practical examples to talk about. I don't have the articles which from the internet, but yes, that's the practical experiences how it's been done. So the examples which I gave during the peak hours, we used to have a we in the typical monolithic architecture, because I have supported all the type of infrastructure. So in the monolithic architecture, we used to still follow the vertical scaling, and well in the microservices and the middleware architecture, we followed the horizontal scaling, where we used to increase the number of VMs while deploying the VMSS in the VMs in the VMSS virtual machine scale set, that is being again controlled by a load balancer. So this is how typically we used to manage from practical experiences. Now this is the second article, again the basic one, very basic one. When you are new to the application scaling, this is and why it matters. So this covers the entire if you are very new to this particular things, there's no panic. You can just go through and couple of these articles and learn more about what is the scalability, and make how can make your application scalable, the web application scalable, or the typical WCF based architecture scalable, so that it when the load increases, then it should automatically handle the traffic accordingly. And then we have a when before moving the things into production, you need to perform the scalability testing by ingesting some testing, so that when this load occurs, then concurrent uses occurs, like how the application will behave. So this kind of scalability testing, performance testing comes into the picture. And why this scalability matters. So this is also a very good experience, like the better user experience, how the like what does like what does how why does it even matter to the scalability. So we are living in a world where without scalability we can't do anything, whether it be watching a movie in the Netflix, or streaming a match, a live match in the Hotstar, Disney Hotstar. So I think we have enough reason to justify like why does the scalability really matters, whether it's the application scalability or the infrastructure scalability. This is some of the examples, and why it saves money as well. Because money saving means like when you are scaling your application, right? The users, when the traffic is huge, users don't have to experience the glitch in the application or the slowness. So when if they face there will obviously loss of productivity and loss of the money for the company. And but when we are thinking about scaling the application, it saves a lots of money. So just go through this particular some of the typical advantages of why we want to the why part, why we want to use Ava, and why it matters, and some of the advantages of scaling the application or auto scaling the application. But when we talk about auto scaling, I think there's a Microsoft Ignite which has happened last month. They are previously it was low code no code. So now the application are coming with a no code purely no code, not even low code. So when you talk about no code applications, the applications are designed to fit in that architecture. It should be a self healing one. So that's a new thing which has been come up in this the last Ignite as well. And I think you can also talk more about it, Vishwas, because Microsoft is focused on the no code applications in the last Ignite as well, which is also supporting this self healing infrastructures also. Yeah,
Yeah, like even if you think of serverless is also improvising day by day. Like there is no stop for that.
yeah,
Everybody wants a different stake in that entire infrastructure. Let me just say something like Cosmos DB as an on DB RBAC assist authentication and things like that. That means they are really thinking back at like what if the compromise happens not just from a DevOps side or else from the developer side. Let it be because of Microsoft, which is just being accessed through an internet. So I think probably that's the way in which people are coming up with the security practices and the technology. So
yeah.
my next question is, how is management taken care? Because fundamentally the challenges have always been there, and how are you seeing it like today in the world of
I typically, this is one of my favorite, not I could say favorite, it's a kind of, it was a nightmare for me when I first entered into incident response management systems. But yeah, it was exciting, as well as uh, I would say I have spent sleepless nights but this process, incident response system, is indeed needed when you are working for e-commerce based applications, or when you are selling something, or when you are working for the selling can be in Amazon as well as a Flipkart or anything or Microsoft. So whenever you are selling anything, this if it is good if you develop this kind of incident response steps. So what happens is typically uh, like when I talk about Microsoft, so it used to have the ICM based workflows, incident management workflows. So what typically used to happen is whenever we need to any kind of product based company should think about developing this the incident response system. Why? Because the early you detect the events and then do the analysis and then do your prioritization and then inform the customers and then you do a recovery and incident review. uh, in the steps, if you perform all these things, the more happy your customers would be, so that they will be in a more confident than if they're investing in your investing in your the products that they have bought. They will get some confidence, so they will see that yeah, this particular company is having a strong instant response setup. So because if you are having a if your company is having a strong instant response, then you are convincing your customers that trust has been established, and they are very confident of the delivery of the product and how it's been. The if you open an issue today incident if you open an incident today, how it's been handled, or if it's unexpected issue also occurs in the production system, how it's been handled. So typically how it used to happen, it works in a 7-step procedure. I've just dotted down some of the points. Let me share my screen again. So when I sorry, so yeah, again let me share my screen.
Sir, can you make your screen a little down so that it's just your hand with your
Okay.
okay, the flexible chair. Sure, I can see your
Yeah,
screen
it's a
now.
flexible chair. Yeah. So this is how the typically it used to happens, and I can also show in the Google ICM workflows how it used to work. But this is the typical steps which we used to follow, and I can correlate with my past experiences as well. So when we talk about incident response steps, so first was the early detection. Like if you detect the early detection happens through I will correlate my example with the scenario with the Azure cloud. Early detection, how it used to happen. We used to configure application inside ping test alerts. So any geographical location had some issues, right? Then we used to the application side used to throw some ping test alerts. It's hey, it's failing in this application with HTTP error codes 500, 400s, or so it typically used to detect that this location is having some problem and which API is causing the issue. So that's typically the early detection, how the early detection works. And the support team used to analyze those logs and get back to the teams. And then this is how the early detection happens. Any the application sites because we can configure lots number of alerts using the application site, that includes the ping test alerts also. Any failure in that you used to investigate, and then that's a kind of early detection. This site and this API in this API call in this particular region is having issue, then that's a early detection, or how you can improvise your production response systems. Then the analysis. So you need to review the alerts which has been fired. So you can just do analysis, how the patterns you can observe, at what time it has occurred. It's any correlation with the patterns, and how you can rule out the false positive alerts, because many a case I've encountered the scenarios where false positive alerts used to trigger, and our support teams were used to panic like this issue has occurred, and we used to check and see all these things that application doesn't have any issues. So you rule out the false positive net when you do the analysis of the when you have the couple of alerts with you jotted down with you, and then you define a pattern, and then you do couple of analysis, and then you rule out those kind of false positive alerts. Then comes the prioritization. Now like you need to understand the impact of the security incidents. So like what according to the organization business activity, like you need to prioritize like what kind of errors or the incidents which has occurred, like like if, for example, there's a potential leak in an application where the port is been port 22 is exposed to the to for let's say an example to the entire world. That should not happen idly. So it's exposed to the entire world. So typically talking about very layman language. So you need to prioritize those incidents first, which actually cause a security breach, and then the notification of that's a very important step. Step number 4. So you need to inform that the incident breach has happened, the security breach has happened. So there's notification of the stakeholders, business partners, and you need to inform all of them, like who are the key stakeholders, your customers. So there's a potential breach has happened, and then you are working on that to mitigate that. The first After that, the next step is the, I think I would say, containment and forensicing. So means the incident response take action to stop the incident and prevent the threat from reinfection in the environment. So they will stop the particular the responders, like this is typically the fifth step could be the you need to found a way so that you can first of all to come out of the situation. You need to mitigate. You can think of step 5 as a mitigation step also. First you need to mitigate, and then step 6 would be the recovery, how to first recover. Whenever we are into incident management, right, you need to first see how we can recover, mitigate first, and then recovery. Once you start identify the issue has happened, for example, one particular region where ping test alerts has failed, and you off the traffic of that particular region, right? So first of all, you have taken a mitigation step, right, to stop the traffic of the region which is having maximum number of 500 hits. So that's where you first perform the mitigation, and then you come after when you have to perform the mitigation, stop that particular region, so that the region which is working fine is serving the traffic to the stakeholders, the customer. Then you have already performed a recovery. So you have come up with the steps, which is called mitigation. Now, the complete recovery depends upon once you have from the mitigation is just a workaround to so that you can recover from that incident. But the actual work starts about on the recovery. Recovery is something you need to check on those which particular API is failing, and then you need to check the event logs or something, and then if you have solved those alerts, then only you can make that lesion live. So that's called recovery. In the fifth step, which is called the containment or the forensic, that is mainly focused on the mitigation step. Recovery is like you have recovered, you have identified, you have analyzed, and you have recovered that particular for example, let's say the region which is serving the traffic. So this is how the recovery happens. And then the incident review. So you might have heard in the typical production scenario, incident review happens, post mortems happen. So this PR generated, which is called the problem statement generated. There is a problem team who performs the incident review, so that the next event doesn't occur for this one. So that's what the problem tickets get created, and then the analyst who were present in this incident is present. That is also who is present in the meeting, and the analyst is also present, service engineer is also present, and then they provide their different perspective and views, so that the repetition of the alert, the incident review doesn't occur. So that's you have a then after the step 8 would be you have a collection of the KB articles or the knowledge articles, where whenever the another events with the same occurrence occurs, right, you can respond to those events very effectively. So this is the eighth step is the having the developing a knowledge article to have an effective incident response system for the production based system. So this is typically a couple of steps which I think I can I think if you want to refer one particular link, I think I can give a link as well. I'm not sure if this is helpful. Yes, this is helpful. This will help you to share the things which are in place. Yeah, so this is the one which I was referring to. like typical ICM. And this is the other thing which I think I have followed in my career, ICM workflows.
Yeah, I think
Intelligent
that's
communication manager for ICM. Yes, correct. This is the create an ICM incident. That is how you we used to work. So this ICM, we see, this is how the ICM ticket incident used to occur. You need to create these events in a create an ICM incident. This was a typical, how we used to manage when I was working. So on this ICM workflows, typically this is what I'm speaking. I was speaking about how this ICM triggers occurs and how the incident. If you want to have effective, incident management response system for production, this is the best example I can refer to. And I have worked on this one, so I know how to online service incident management system for. And I think there is a good video as well, which talks about the online service incident management. To refer to, let me. Just to get a gist what I was referring, this is the exact video. How this should be handled effectively, the incident management for the production systems. Yes, Vishwas, over to you. I think I've given enough of things which I had on the incident
yeah.
management. Yeah.
Hey, I think that's the best part, right? Everybody knows what to be done in an infrastructure, but lately, what really defines our presence in the market is how much is our SLA. Like, you
SLA,
might
yeah.
talk, you might talk anything which is crazy amount of insights, but guess what? At the end of the day, it's all SLAs that come and sit in your boardroom, and people say, you know what, this is what we are having. I think Benaka, thanks for joining in. Means a lot. So this is the end of it, my friends. There is. I think he didn't leave any points about auto healing and the remediation, because there was a lot of things covered based on the security aspect, adoption, as well as his experience in different. Yeah, yeah,
Remediation, of course, like see, typically speaking, I have heard this term first when I was working. There's a tool in my Azure called Azure Defender. So when you enable that one, that's comes up with a 30 days free trial, and when you enable that, you get lots of recommendation or a offer infrastructure which is hosted on the Azure, which can be on premise as well with the help of yeah, the tools which are coming up now. Azure Arc, you can have the on premise infrastructure hosted in the Azure itself. It discovers actually, and then you can have remediations. It give you recommendations, and then you have to work on those recommendations. So when you work on the recommendations, then Microsoft recommends you some of the remediation steps which you can take to stop the future threats which can occur. And this automation, I will give you a simple example how you can automate the remediation. So when you all might have worked with the Azure VMs, right? And Azure VMs, so you might have configured runbooks as well. So when you configure Azure runbooks for Azure VM, it automatically helps to remediate the things automatically. Like for example, like to start stop the VM at a particular time and restart a VM, and you can automatically remediate Azure VM alerts with the Azure automation runbooks. This is a typical example which I have configured Azure runbooks for remediating the, for example, to start stop a VM, or typically do perform an administrative task, right? To remediate to stop incurring the cost. You can configure the runbook or the webhook, which can do a lot of things for saving the cost, and then remediating the some of the alerts as well, like copying and pasting the webhook during the alert creation. So the one of the things which is a very basic basic example of how you can automate the remediations which has been provided by the Azure Defender service for because for the remediation. So Defender service is one, and Azure Defender service, and then Azure Sentinel is the one which can help automate your remediations. And Azure Runbooks, of course, they can the example which I've pinged, which can help you remediate some of the alerts which are caused with the Azure VM. So that's the last part which I can tell on some of my experience on automating the what is remediation and how to typically automate it. Yeah, um, that's what. Yeah,
Sure, sir. Thank you so much for such great insights. I think let's connect soon for another impactful DevOps chat series. Of course, there is another set of guests planned, and we are
okay.
getting
Yeah,
more some more people in where they are actually giving a lot of insights about the technology and the things like that. So meet you guys
that's great.
soon. Bye, folks. I'll end the broadcast now. So this is
Sure.
Vishwas Tan
Thank you.
signing off from the show.